Now guys, in preparation for our final examination, I took this question paper from November 2018, paper 1, grade 12 mathematics. I hope you're gonna enjoy this lesson today. Let us just start with question 2 of sequence and series. Now, question 2, it says that given the quadratic sequence, now note that this is a quadratic sequence, 2, 3, 10, 23, and etc. The first question, 2.1.1, it says that write down the next term of the sequence. Now, from the given sequence, you must write the next term. Basically, our first term, second term, third term, fourth term, and you must write the next term after 23. Now, for us to find the next term, in this case, for quadratic equation, for quadratic sequence, guys, we know we're talking about the constant second difference. The constant second difference. Now, let us find the first difference. Term number 2 minus term number 1. Come on, 3 minus 2, it's 1 again. Term number 3 minus term number 2, 10 minus 3, it's 7. Now, 23 minus 10. Term number 4 minus term number 3. Our answer here is 13. Now, you need to check the trend. From 1 here, how did you arrive to 7? We added 6 again. And how did you arrive to 13? We added 6 again. Now, come on, for us to reach 7, we added from 1 to 7, we added 6 again. From 7 to 13, we added 6 again. That's a very, very important point here. So remember now, for us to find the next term in this case, guys, for us to find the next term, we need to understand when we minus, we go that side, and when we add, we come to the right. So we're gonna add 6 again here. So we're gonna say 13 plus 6 and here. Keep guy in 19. Now, for us to find this 19 will help us to find the next term here. How are we gonna find that? We know 2 plus 1 is 3, 3 plus 7 is 10, 10 plus 13 is 23, 23 plus 19 is 42. The next term is 42. I hope we are clear. This is how you find the next term of a quadratic sequence. Are we clear? Yes, guys. Now, let us leave it like that. Let us go to 2.1.2, find the nth term of the sequence. Nth term. Now, apologies. Nth term of the sequence, it is generally the formula for this quadratic sequence. That's the basic logic behind the general term. Now, how do you find the formula for quadratic sequence? In quadratic sequence, we need to find the second constant difference. Now, this one is our first difference. Now we need to find the second difference. How do you find the second difference? We do the exactly thing that we did here. We say term number 2 minus term number 1, term number 3 minus term number 2, term number 4 minus term number 3. That's how we're going to find the second difference. Hurry. And it should be constant, remember. 7 minus 1, 6. 13 minus 7, 6. 19 minus 13 is 6. Come on, someone. This second difference, it is constant. That's very important. And this is how you're going to find the general term for this sequence. Now, this 6 is our second constant difference. You just need to include constant difference because it's 6, it's constant. Yeah, that's how you find the second difference. So this only applies to quadratic equation. Okay? Then we have a general formula. So in this case, for us to find, about the general formula for quadratic equation, Tn is equals to an squared plus bn plus c. Now, the value of a, the value of b, and the value of c. This is the formula you must understand and know when going to an examination. This is how you find the value of a. You need to know this formula, guys. 2a. This is the formula. 2a is equals to second constant. You can say second difference. Second constant difference. Very important. Now, now, what is our second constant difference? Is 6. You put, where is the second constant difference? You put in 6 here. You put 6 here and equal to 2a. Then you divide both sides by 2. And a, therefore, a is equals to 6 divided by 2 give 3. Come on, the value of a is equal to 3. Are we clear? Yes. Then now, we're not done. Tn is equals to a, I want to get 3. You just, where is you put in 3 out? 3 n squared plus bn plus c. Very important. Now, another thing that you must understand is that you should find b and c. Now, how do you find b and c? Simultaneous equation. Always, in quadratic equation, you must go through the root of simultaneous equation. Now, how do you find b and let's start with, we must have 2 equations. That's simultaneous equation basically. Let us check something from our sequence here. We've got term number 1, term number 2, and term number 3, term number 4, and so on. Now, term number 1 is equal to 2. Are we clear? Are we clear? Basically, I'm going to substitute where there is n, there is 1. Here's our 1, here's our n. Now, from this equation, where I see n, I put in this 1. Are we clear? Come on, for term number 1. For term number 1, where I see n, I put in 1. From this equation, where I see n, I put in 1. 3 times 1 squared plus b times 1 plus c. Guys. Then 3 times 1 squared get 3. 3 plus b plus c. Remember, for term number 1, term number 1 is equal to 2. Come on, where I see t1, I put in 2. I'm going to put 2 here. Very important. I hope you saw what I did there, guys. Where I see t1, I put in 2. Here's my t1, therefore I put in 2. Where I see n, I put in 1. Here's my n, I've put in 1 here. That's how we do it. Are we clear? Now, let me just transpose this 3 to the left. 2 minus 3 is negative 1. Minus 1 is equals to b plus c. This is my equation number 1. Are we clear? This is how you find the first equation of our quadratic equation, sequence. Now, equation number 2. Here we have got 2 variables, b and c. Hence, we use the quadratic equation to find the third, or to find the 2 variables in one equation. Wow. Now, we are not done, guys. I don't know. Yeah. Hurry. Now, term number 2. Term number 2. You can take any term as long as it's on a sequence. T2 is equals to 3. Yeah. Now, from this purple equation, where I see n, I put in 2 from this. T2 is equals to 3 times 2 squared plus b times 2 plus c. Now where I see T2, I put in 3. I put 3 here. T3 equal to, remember, term number 1 is equal to 2. Term number 1, term number 2, term number 2, term number 2, term number 3. That's how we do it. You can take any term number. It's your choice. Hurry. 2 squared is 4. 4 times 3 is 12. 12 plus 2b plus c. Okay? Now, I'm going to transpose this 12 to the left. Okay? So I'm going to have 3 minus 12. Okay? Negative 9 is equals to 2b plus c. Equation number 2. I'm done. Are we clear? Yes, that's how we do it, guys. I'm not done, by the way. I'm not done, guys. Now, I've got 2 equations here. I've got 2 equations. And for me to simplify, this is simultaneous, basically. For me to continue with this 2 equations now, I can use negative 9, equation number 2 minus equation number 1. Negative 9 equal to 2b plus c. Minus equation number 2 from equation number 1. Then equation number 1 at the bottom is negative 1. Equal to b plus c. So I'm going to minus here. C minus c is 0. 2b minus b is b. I write b here. Negative 9 minus negative 1. Come on, so negative 9. When you say minus, it will be negative 9 plus 1. Okay? Negative 8. This is the value of b. Are we clear? Are we clear, guys? I hope we are very much clear. Now, I found b, which is my negative 8. How can I find c? I can use any of the 2 equations to find c. So now I know what is my value of b. Now, to find c, I'm going to say I can use either of the 2 equations. The simplest one is this one. I'm going to say, therefore, minus 1. I can use equation number 2. This equation number 1. This one. Negative 1 equal to, where I see b, I put in negative 8 again. Negative 8 plus c. Then now, negative, then I'm going to transpose this negative 8 to the left. Negative 1 plus 8. The answer there is 7. Therefore, my c is equals to 7. Are we clear? Then our equation here is going to be Tn is equals to 3n squared. For b is minus 8n, and for c is plus 7. This is our general nth term of the sequence. 3n squared minus 8n plus 7. Are we clear? Are we clear, guys? That's how we do it. I hope we are all clear. There are many ways to simplify, to find there are many ways to simplify out these types of equations. There are many ways. This is one of the ways. This one is the way, I think this is the simplest way of using simultaneous equation. This is the simplest way to find the general term of the sequence. I hope we are all clear. We are all clear. 2.1.3. Calculate the 20th term of the sequence. 2.1.3. You must find the 20th term. Come on, someone about a T20. T20. Or a T20. 20th term. T20 is equals to, I give what this, where I see n, I put in 20. Where I see n, I put in 20 from this equation. Hurry, n, I get 3 bracket 20 squared minus 8 times 20 plus 7. Remember that term number 20. Then we put that inside the calculator and get, then our answer is going to be 1047. This is our final answer for 2.1.3. Are we clear? Question 3. It says that there's a constant ratio of 1 over 2. Our R is equals to 1 over 2. Constant ratio. It's R yarona. And the sum to infinity S and our infinity is equals to 6 in this case. Our sum to infinity is 6. Well, guys, this is how it looks like. Well, now the first question will say that 3.1, calculate the first term of the series. First term, I just remember in geometric and both in geometric series, our first term is the value of A. Is the value of A, or its symbol is A, basically A, and we are given the value of our sum to infinity and the value of R. Remember the formula of sum to infinity. It says that sum to infinity is equals to A divided by 1 minus R. Well, very simple. What is the value of our sum to infinity? It is 6. So we're going to write 6 here equal to A 1 minus 1 over 2. Well, then you solve for A. You just in this case you cross multiply. What's about A times 1? A times 1 is A. Then 6 multiplied by 1 minus 1 over 2. Our answer is 3 there. Then you are done. This is how you find the value of A. This is our first term. First term, I want to give it A basically. That's how you find A. Now 3.2. 3.2. It says that calculate the 8th term of the series. 8th term of the series. Now the 8th term. How are you gonna find the 8th term? For us to find the 8th term, we need to know the formula of the geometric series, of this geometric series. How do you find the formula for geometric? Whatever Tn is equals to A R to power n minus 1. Remember, the value of A is our first term, which is 3. We call it 3 fella. R is our constant ratio, is 1 over 2. 1 over 2. Then n owner, it's like that. This is our general, this is our formula. I hope you are clear. Now you answer the question here. Calculate the 8th term. Come on, T8. 8th term. Where I see n, I put in 8. So I have 3 multiplied by 1 over 2 to power. I get to power 8 minus 1. 8 minus 1. 8 minus 1. Yes. Then you put this on a calculator. All of it is gonna give you 3 over 128. Are we clear? Yeah. This is our answer here for this question. We are clear. We are very much clear, guys. Yeah. Very simple. From the very same question paper, we go to 3.3. 3.3. 3.3 says that we are given. It's given that our sum to series. Here we've got our n and our k is equals to 1. We've got our general formula 3 multiplied by 2 to power 1 minus k is equals to 5,8125. The question is that calculate the value of n. Remember, n on the top. N is our series is gonna start from 1 and it ends at n. So we want to find the value of the last value which is the value of n. How are we gonna find the value of n? for us to find the value of n, remember, we need to understand ukuthi this is the geometric series and it has its formula. This formula you use when you find answers using or in a series format. Sn is equals to a 1 minus r to power n all divided by 1 minus r. This is the formula we use in the sums of geometric series, because it's got the value of a, which is our first term, the value of r, which is our constant ratio, and the value of n. But like this n, basically our sum 2 series, its value is this one, 5,8125. All the time, if you're given the value of this one, then you know this is our sum 2 series. Now, how do you find? Now, our aim here is to find the value of r. We don't know the value of r. We're gonna use this formula to find the value of r. We're going to say 3 multiplied by 2 to power 1 minus 1. I give a table, we start from 1. Where is it here? Put in 1. I start from 1. I'm going to say plus 3 multiplied by 2 to power 1 minus 2. I'm going forward. Plus 3 multiplied by 2 to power 1 minus 3. Then plus etc. You do that. We start from 1, 2, 3 and going forward. Yeah. Then I'm gonna simplify that one. Give us about 2 to power any number to power 0. We put this on the calculator. 3 times 2 to power 1 minus 1. The answer is gonna be 3 plus. You put that on the calculator. 3 multiplied by 2 to power 1 minus 2. The answer is 3 over 2 there. Plus, you put this one again. 3 to power 3 multiplied by 2 to power 2 to power 1 minus 3. The answer is 3 over 4. 3 over 4. Now, for us to find the value of r, or the constant ratio, we are going to divide term number 2 with term number 1 and term number 3 with term number 2. I'm going to divide them. I'm going to say 3 over 2 divided by 3. And get constant ratio. This, you do this in geometric. You divide in geometric. 3 over 2 divided by 3, it gives me half. And when you say 3 over 4 divided by 3 over 2, it's going to give you 1 over 2. This is our r. This is the value of r. They're going to put it here. Our aim was to find the value of r. We know the value of a, the value of r. We know the value of Sn, the value of r. That's how we find the value of r. Sum 2 series is 5,8125 is equals to, what is the value of a? Remember, the value of a is 3. First term, 3 bracket 1 minus, what is the value of r? Is 1 over 2. 1 over 2 to power n. You close the bracket, all divided by 1 minus, the value of r is 1 over 2. Are we clear, guys? Then now, n. Whatever, if this is the case, then I'm going to say, since I'm multiplying here and there are no variables at the bottom, I can literally divide this 3 with 1 minus 1 over 2. I can say 3 divided by 1 minus 1 over 2. The answer on my right is going to be 6. 6 bracket 1 minus 1 over 2, close bracket to power n, close bracket equal to 5,8125. Then I'm going to divide both sides by 6. By 6 so that I can be left with this bracket only. 5,8125 divided by 6. The answer there is 31 over 32 is equals to 1 minus 1 over 2 to to power n. Then I'm going to transpose this 1 to the left. I'm going to say that 1 over 2 minus 1 it's going to give me negative 1 over 32 is equal to negative 1 over 2 to power n. We don't need these negatives on both sides, so I can remove them. You know, when you divide negative by negative, it's going to give you positive. So I can divide with this negative on both sides and they're going to be removed literally. So you don't need to stress about them. I divide both sides by negatives. There is going to be only positives here. Then now I have this type of equation. 1 over 32 equal to 1 over 2 to power n. Now I've got the powers, the exponents here. This is an exponential equation, and for me to solve exponential equation, I need to make sure that my bases are the same. How am I going to make sure that my bases are the same? Remember, I can break this 32 and give it another 2 more. That means I can make sure that my 2's are the same. Since I can literally change this 32 and say, which number can it multiply itself, irrespective of how many times to give us 32? Which number can it multiply itself, irrespective of how many times to give us 32? As long as that number is 32, if it multiplies itself, irrespective of how many times, you can say 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4. 2 times 2 times 2 times 2 times 2 is equals to 32. We have got 1 over 2 to power 5, which means 2 5s, they give us 32. And that's how you break it. That's how you do it, guys. You must find any number, as long as that number it can multiply itself to give us the very same number that you want, which is 32 in this case. And you found 2 there. I just want, our aim is to make sure that the bases are the same. This one is equals to 1 over 2 to power n. Are we clear? Now remember the inverse. You remember the laws of inverse. I don't need these fractions. So for me to remove them, I'm going to introduce the reciprocal, basically, about the inverse in anyhow you want it. I can say the reciprocal, or for me to remove this negative, this fraction, the answer here is this exponent is gonna carry a negative sign on it. So I'm gonna have 2 to power negative 5 equal to the very same thing I'm gonna do on this part. 1 over 2, its inverse is 2 to power negative 1. 2 to power negative 1 is the same as 1 over 2. I didn't change anything. Then this negative 1 times n is negative n. So to negative n. Then when bases are the same, I equate the exponents. Negative 5 is equals to negative n. I don't need these negatives. Therefore, I'm going to divide both sides by this negative. I can divide divide by negative on both sides. So when you divide both sides by negative, they want to be removed, both of them. You won't do that if and only if there are negatives on both sides. You can divide by them and you're going to give us positive answers. Therefore, the root of n is 5. That's how you find the root of n in any equation of this kind of geometric sequences. Are we clear, guys? Yes, thank you very much for your time.